Let's practice simplifying fractions using prime factorizations and the GCF together. If you'd like to download this free PDF and print it out and do these with me, feel free to do so. You can find that in the description. And within those links, you'll also find some other free resources as well. And while I know there's some different strategies for simplifying fractions, in this one I'm going to go about using the prime factorization method so you can see how that ties into it. For number one, we have the fraction 5/10. So what we do is we find the prime factorization for the numerator. So the prime factorization of 5 is just going to be 5. And then we find the prime factorization of the 10 on the bottom, which is just going to be 2 times 5. If you need to go ahead and make factor trees, go ahead and do so. This one's not too bad though. So when we go ahead and use these prime factorizations, what we can do is we can cross off anything that matches on top and bottom because 5 over 5 is just equal to 1. And if you ever cross off everything on the top or the bottom, there's just a 1 left, so we're going to have 1/2 here. Because we crossed off a 5 on top and bottom, technically the GCF here was going to be 5 between the top and the bottom. For number 2, we have 9/15, so 9 will break into 3 times 3 for its prime factorization, and 15 will break into 3 times 5. Now what do they have in common? Well, they both have a 3 on top and bottom, so this simplifies down to 3/5. Because we crossed off a 3 on top and bottom, the GCF for this fraction for the numerator and denominator is just 3. For number 3, we have 8/10, so 8 will break into 4 times 2, but then 4 will break into 2 times 2, so really 8 is just made up of a 2 times a 2 times a 2, and then a 10 will break up into a 2 times 5. On top and bottom, we can cross off a 2 on both locations, so 2 times 2 on top, we're left with 4, and on the bottom, we're left with 5. Because top and bottom both had a 2 in common, we know the GCF between the numerator and denominator is 2. Let's try number 4. For number 4, we have 12/15, so the prime factorization for 12. 12 breaks into 2 times 6, and then 6 will break into 2 times 3. So that's the prime factorization for 12. And then for 15, we have 3 times 5. All right, top and bottom, they both have a 3, and that's it. We're left with 2 times 2 on top, which is 4, and on bottom, we just have a 5. So that's going to be the most simplified fraction. Because we crossed off 3 on top and bottom, that is the greatest common factor for both top and bottom. For number 5, we have 15/10, so 15 breaks into 3 times 5, and 10 breaks into 2 times 5. They both have a 5 in common, so we can go ahead and divide those out or cross them out, and we're left with 3/2, or 3/2. The GCF that we divided both top and bottom by was 5. For number 6, we have 24/10. 24 breaks into 2 times 12. 12 can break down into 2 times 6, and 6 can break into 2 times 3. So we have 2 times 2 times 2 times 3 for the prime factorization for 24, and for 10, we just have 2 times 5. Now, the numerator and denominator both have a 2, so we can go ahead and cross those out. And I think that's it. So we're left with 2 times 2 times 3, which is going to be 12 in the numerator and 5 in the denominator. So we still have an improper fraction. And you can leave it like an improper fraction. That's also okay here. We're not practicing converting. We divided top and bottom both by 2, so that's the GCF. For number 7, we have 24/18. Now, if you already know the prime factorization for 24 from number 6, feel free to just go ahead and copy it because it's the same prime factorization. After a while, when you practice these, they get easier since they're all the same. 18 breaks into 2 times 9, then 9 breaks into 3 times 3. So that's the prime factorization for 18. Now the top has a 2 on top and bottom. They both match, and they both have a 3. So what's remaining? What's remaining is 2 times 2 on top is 4, and on bottom we're left with a 3. And for the GCF, be careful, make sure you multiply the 2 and the 3 together. That makes 6. Okay, so it's both numbers crossed out, multiplied together. That means we divided 24 by 6 and 18 by 6 to get the most simplified fraction. For number 8, we have 28/21, so 28 breaks into 2 times 14, and 14 breaks into 2 times 7. So 2, 2, and 7 is the prime factorization. For 21, that just breaks into 3 times 7, and top and bottom both have a 7, so we can go ahead and cross those out. So 2 times 2, we're left with 4, and then left with a 3. So the GCF, well, we divided both in top and by, technically we divided them both by 7. That's the GCF. For number 9, we have 18/30. So we actually just did 18 a little bit ago, so you can look at that prime factorization. So that's going to be 2 times 3 times 3. For 30, we can divide that by 2, or that's left with 15, and then 15 breaks into 3 times 5. Top and bottom both have a 2. Top and bottom both have a 3. So if we cross those out, we actually have a simplified fraction of 3/5. okay? Because we crossed out a 2 and a 3 on top and bottom, we technically just divided the whole fraction top and bottom by 6. 2 times 3 is 6. For number 10, we have 35 over 40. 35 breaks into 5 times 7. Those are the prime factors. 40 breaks into 2 times 20. 20 breaks into 2 times 10. 10 breaks into 2 times 5. So that's the prime factorization for 40. Top and bottom both have a 5, cross them out. That's going to be the GCF. We're left with 7 over, and 2 times 2 times 2, that's going to be 8. So we have 7/8. And technically, what did we divide top and bottom both by? The GCF was 5. For number 11, we have 24 over 36. We've done 24 a few times now. That's just 3 2s and a 3. That's the prime factorization. And for 36, that breaks into 2 times 18. And if you look up at number 9, we actually know 18 breaks into 2 times 3 times 3. What do we have in common? They both have a 2, they both have another 2, and they both have a 3. So what are we left with? We're left with 2/3. And what did we technically divide the whole fraction by top and bottom? Well, let's just multiply the numbers we crossed out together. So 2 times 2 is 4, 4 times 3 is 12. So technically 24 divided by 12 and 36 divided by 12 got our simplified fraction. For number 12, we have 28 over 42. So 28 we've done already, that's 227, okay? Again, you can make trees if you need to. 42 breaks into 2 times 21, 21 breaks into 3 times 7. Top and bottom both have a 2, and top and bottom both have a 7. So if we get rid of those, then we just have the most simplified version, which is 2/3. What was the GCF? If you're thinking 2 times 7 is 14, that was a GCF, then you are correct. For number 13, we have 30 over 40. That's going to be 2 times 15. 15 is 3 times 5. For 40, we already used this one. That's going to be 3 2s and a 5. Again, if you look at some previous problems, you can save yourself a lot of time. 2 times 2, those 2's are going to go away, and 5 and 5. So I meant 2 divided by 2 rather, right? So the 3 on top is going to stay as a 3, and the 2 on the bottom make 4. And so that's the most simplified fraction. The GCF here is going to be 10 because we crossed off a 2 and a 5 on top and bottom. For number 14, we have 32 over 48. 32 is an interesting one. I know off the top of my head it's going to be 5 2s. I've just done it enough times. If you need to make a tree, go for it, or you can also memorize that for the future. 48 is 2 times 24, but then we did 24 a bunch of times. 24 is just 3 2s and a 3. Okay, so 2s cancel, another pair of 2s, a third pair of 2s, and a fourth pair of 2s. So a lot crosses out here, and we're left with 2/3. So technically, what did we use for the GCF? What did we divide top and bottom both by? Well, we crossed off 4 pairs of 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So technically, we just divided top and bottom by 16. For 15, we have 21. That's going to be 3 times 7. And on the bottom, we have 28, which we've done a few times now. That's 2 times 2 times 7. Top and bottom both have a 7. Let's get rid of those. Then we're left with a 3 on top, and then 2 times 2 on bottom is 4. Now, the GCF for top and bottom is going to be 7. For number 18, we have 18 over 27. So 18 we've done, that's 2 times 3 times 3. And 27 on bottom, that's going to be 3 times 3 times 3. So what do they have in common? They both have a pair of 3's and another pair of 3's. So actually this fraction is 2/3, as well as some of the other ones we've done. And technically we divided top and bottom by 9 because 3 times 3 is 9, the 2 3's that we crossed out. Let's try some more. Let's check out 17. So from 17 on, I'm actually going to alternate between using the ladder method and the prime factorization method, and feel free to use whichever method you prefer. Some people like this method more, but you do have to do a little bit more in your head in terms of knowing divisibility rules and such. So you can actually take the ladder method and then just write a fraction inside of it and then simplify it that way too. So what goes into 30 and 45? I think 5 is a pretty common number. 5 times 6 is 30, and 5 times 9 is going to be 45. And then what goes into 6 and 9, I'm thinking 3. 3 times 2 is 6, and then 3 times 3 is equal to 9. So what's nice is this over here on the side tells you the GCF right away, which is 15. So what we're doing is we can divide the top by 15 and the bottom by 15. And the numbers that we have at the bottom here, this 2/3, is actually going to be the most simplified fraction, 2/3. Okay, so that's what we have here in terms of using the ladder method. Okay, for 18, I'm going to go back to prime factorization. 24 is 2 times 2 times 2 times 3. And then 32 is going to break into 2 times 2 times 2 times 2 times 2. We've actually done 32 as prime factorization on the other page as well. They both have a 2, they both have another 2, and they both have a third 2. And so what are we left with? We're left with 3 on top, and then 2 times 2 on bottom. So we're going to end up with 3/4 here for our most simplified fraction. Again, what's our GCF? Well, the ones they had in common there was 2 times 2 times 2, so technically we divided top and bottom both by 8. And that's how we got 3/4. For 19, we have 42 over 56. So let's try using the ladder method just to give it a try and get better at this method as well. I think that maybe people might think of 7 because 7 times 6 is 42, and then 7 times 8 is 56. And then for 6 and 8, I might notice that they're both even numbers. You can divide them both by 2. And half of 6 is 3 and half of 8 is 4, right? So over here on the side, 7 and 2 should make the GCF of 14. So you can divide top and bottom by 14. That's what we found out. And then this 3/4 at the very bottom here, that's the most simplified version of 42 over 56. For number 20, let's try using prime factorization. So 38 is an even number, so we know it can go in 2 times something is 38. Turns out that's going to be 19. So either use a calculator or do long division. And for 57, if you know your divisibility rules, 5 plus 7 is 12, which is a multiple of 3. So it turns out 3 times 19 is 57. Okay. They both have a 19, which is kind of nice. And so that means you can divide top by 19 and bottom by 19 as well. So that's the GCF. And we're going to be left with this 2 and this 3. And so this simplifies down to just being 2/3. For number 21, we have 45 over 15. So let's go ahead and use the ladder method here. So we'll put 45 and 15 next to each other, just like this. And let's see what goes into both of them. I can say with 5 is pretty straightforward. 5 times 9 is 45, and 5 times 3 is going to be 15. We can put fraction bars here. And then what goes into 9 and 3? 9 and 3, I think 3 goes into both. 3 times 3 is 9, and 3 times 1 is 3. And so we can go ahead and say that 15 here would be the GCF, so we can divide this by 15 on top and divide by 15 on bottom. And we're going to be left with this 3 over 1 on the bottom. So we're going to write 3 over 1, and we can just go ahead and write 3 if we would like to. All right, so that would be the most simplified version of 45/15. For 22, let's go ahead and use prime factorizations. So I know 81 breaks into 9 times 9, but each of those 9s can break into 3s, right? So it's going to be 3 times 3 times 3 times 3. And for 54, I know that's going to be 9 times 6, and then 9 breaks into 3 and 3, and 6 breaks into 2 and 3. So 2 times 3 is 6, 3 times 3 is 9. So that's the prime factorization for 54. These 3's cancel, another pair of 3's, and a third pair of 3's. So what are we left with? We're just left with 3 over 2. So that's going to be the most simplified version here, 3 over 2. Now, what did we cross out? 3 pairs of 3, so 3 times 3 is 9, 9 times 3 is 27. So that would be the GCF. Technically, if you divide top and bottom by 27, you'll get 3 over 2. For 23, we have 42 over 28, so let's go ahead and use the ladder method, 42 over 28. Let's see what goes into both of these. Let's go through our multiplication facts. I'm thinking maybe 7, right? 7 times 6 is 42, and 7 times 4 is 28. 6 and 4 are both even numbers, so let's put a 2 out here. 2 goes into 6 3 times, and 2 goes into 4 2 times. So over here, 7 and 2 make 14 for the GCF. So we can divide this by 14 and divide this by 14, and we're going to be left with this 3 over 2 at the very bottom, so 3 over 2 would be the most simplified fraction. So for 24, we have 75 over 45. I know I can divide this by 5. Okay, so we're going to have 3 times 25 is 75, and then 25 breaks into 5 times 5. And then for 45, that's 9 times 5, but then 9 breaks into 3 times 3, so 3 times 3 times 5. All right, these 3's are going to cancel and these 5's are going to cancel, so we're left with this 5 over 3. So we can say that this simplifies down to just 5/3. All right, now we crossed off a 3 and a 5. 3 times 5 is 15. So that is the GCF between the top and the bottom. Cool. Moving on to 25. For 25, we have this 56 over 28. Let's go ahead and use the ladder method for this one. So for the ladder method, we'll put 56 and 28 next to each other, 56 and 28, and see what they have in common. I'm gonna go with 7 here because I know 7 times 8 is 56, and then 7 times 4 is 28. And then for 8 and 4, I'm gonna put a 4 on the outside here. 4 times 2 is gonna be 8, and then 4 times 1 is going to be 4. So it looks like this actually simplifies down to a whole number. So 7 times 4 is 28, so that's the GCF. Makes sense because 28 times 2 is 56. And this is what we're left with. We're left with 2 over 1 because 56 is double of 28. And you can also write that's equal to 2 if you'd like. All right, for 26, let's do the prime factorization. We've done 48 already if you want to flip the page over or go back to it. So 48 is 4 2's here multiplied by a 3, because I know 16 times 3 is 48. And then for 60, I think that's going to be a 2 and a 2 and a 3. That's 12. 12 times 5 is 60. So they both have a 2, they both have another 2, and they both have a 3. And what are we left with? We're left with a 2 and a 2 on top, and then a 5 on bottom. So on top, 2 times 2 is 4, and on bottom we have 5. Now what did we technically divide top and bottom by? Well, 2 times 2 is 4, 4 times 3 is 12. So the GCF between the top and bottom happened to be 12. For 27, we have 16 tenths. So let's use the ladder method, 16 tenths, side by side. What goes into both of these? The only thing I can think of is 2. 2 times 8 is going to be 16, and 2 times 5 is going to be 10. So looks like 2 is the only thing they have in common, so that's the GCF. And what are we left with at the bottom here? It's 8 and 5. So we can just write 8/5. So that one's a pretty short one. For 28, let's use prime factorizations. For 18, we've done this a few times as well. That's 2 times 3 times 3 if you want to look back at a previous one. And then 72 breaks into 8 times 9. 8 breaks into 3 2's, and 9 breaks into 2 3's. So 2's are going to cancel, and 3's are going to cancel, and another pair of 3's are going to cancel. So the top, we have nothing left, so go ahead and just put a times 1 up there if there's nothing. And then on the bottom, we're left with a 2 and a 2. So this happens to be 1/4. So keep in mind, if everything cancels out, there's a 1 there, okay? We crossed off a 2 and a 3 and a 3, so 2 times 3 is 6, 6 times 3 is 18. So if you divide top by 18 and the bottom by 18, you do get this 1/4. Check out these last few. So for 29, we have 72 over 90. Let's use the ladder method for this one. So 72 over 90. And think of your multiplication facts and try dividing here, but I'm thinking of 9. 9 times 8 is going to be 72, and 9 times 10 is going to be 90. And then for this 8 and 10, I'm thinking of a 2 because they're both even numbers. 2 times 4 is 8, and 2 times 5 is 10. So this 9 and 2 on the side happen to make the GCF. So that means you can divide 72 by 18 and 90 by 18. And this 4/5 on the bottom represents the most simplified version of this fraction. So we can write 4/5. For 30, let's try the prime factorization. So 72 we actually already did in a previous problem. And if you remember, that's 3 2's and then 2 3's. And over here for 120, you can divide that by 2, and now that's 60. And you've done 60 in a previous problem, but 60 breaks into 2 times 2 times 3 times 5. Okay, that's the prime factorization. And then we can just see what they have in common. So they both have a 2, they both have another 2, they both have a third 2, and they both have a 3. So it turns out we're left here with this 3 and 5. So the most simplified version for this is going to be 3/5. Now, what do they have both in common? So 2 times 2 is 4, times 2 is 8, times 3 is 24. So essentially, we divided 72 by 24 and 120 by 24 to get 3/5. For 31, we have 52/39, so we have an improper fraction, so 52 over 39. So just make sure when we write our answer, we still have a bigger number on top. And this one might be a little bit tricky for you if you're not sure about your divisibility rules. This one's a little bit strange, but let's see here. I think it's actually going to be 13. So this might be one where prime factorizations might be more useful for more people. or if you knew it, then that's also really good. I'm just aware 13 times 4 is 52 because there's 4 suits in a deck of cards, and each one has 13. 13 hearts, 13 diamonds, 13 clubs, 13 spades. And then 3 times 13 is 39. Okay, so the GCF here is going to be 13, so both of these are divisible by 13. And we're left with this 4 over 3, which is still an improper fraction, which is what we were looking for anyway. Finally, for number 32, we have 80 over 64. 80 breaks into 2 times 40, 40 breaks into 2 times 20, 20 breaks into 2 times 10, 10 breaks into 2 times 5. So 80 is just 4 of these 2s and 1 of these 5s. For 64, that's actually going to be 6 2s. That's another one that if you've seen it enough, you'll just know it. And we can cross out, let's see, 1 pair, 2 pairs, 3 pairs, 4 pairs. We had an improper fraction, so we should still have an improper fraction. So this is just going to simplify down into being 5 over 4. Now what did we cross out? We crossed out 4 2s, so 2 times 2 is 4, times 2 is 8, times 2 is 16. So we divided top and bottom by 16 as our GCF to get our simplified fraction of 5/4. So if you knew how to simplify fractions before, that's wonderful, but sometimes you may be wondering if you can simplify more or if you can keep going, or your teachers has asked you to keep going with your simplifying. And this is how you can have a foolproof plan for simplifying and not have to ever wonder if you can simplify more. So you can use prime factorizations or the ladder method, and whatever you're left with at the end is going to be the most simplified fraction. So hopefully you found this video helpful. If you did, please consider giving it a thumbs up and let me know in the comment section down below. If you have a preferred method for simplifying, then please let me know too. So keep up the great work, and I'll see you in the next one.